Hello, myself Mr. NILESH MASKE. My subject is chemistry. Now I am going to teach you our next topic, that is chemical kinetics. Chemical kinetics. So I am going to tell you the brief information regarding chemical kinetics. The word chemical associated with chemical reactions. The word chemical associated with chemical reaction. As we know, there are so many chemical reaction which is happening in organic chemistry and in day-to-day life also. Okay, now the word kinetics indicates rate or speed of chemical reaction. The word kinetics indicate rate or speed of chemical reaction. What is meant by rate or speed? Let us say I am telling you my speed of my bike is 40 km per hour. Okay, that is also called as rate. Okay, speed of an object. Okay, the word chemical associated with chemical reaction and the word kinetics concerned with rate or speed. Now, there are three most important characteristics which are described for rate of chemical reaction. There are three criteria which describe rate of chemical reaction. Number first, the extent of chemical reaction. Extent of chemical reaction. Number two, feasibility. Feasibility of chemical reaction. Number three, rate of chemical reaction. Rate of chemical reaction. Now let us see one by one. Okay, extent. The word extent you are already studied in 11th standard. I think the chapter the named chemical equilibrium, where the assumptions of Kc and Kp or uses of Kc and Kp, that point you studied the extent of reaction. Extent of reaction means the reaction takes place in specific direction. The word extent represent direction. The reaction takes place in specific direction. Is called as extent of reaction. Okay, I think the reaction which is happening, the extent regarding generally Kc and Kp, the Kc increases, concentration little bit decreases. You are detailed study in 11th standard. So I am just taking short form. Word extent of reaction means direction of reaction. The word feasibility indicates whether the reaction is possible or not. Whether the reaction is possible or not. I think whether the reaction takes place or not. Okay, reaction will continue. Then the word rate of reaction. The word rate of reaction. That's now we are going to study in this chapter here. The word rate of reaction. Rate means speed. Speed of reaction. Let us say I am going to a distance by speed 40 km per hour and you are going to a distance by speed 60 km per hour. Okay, that way rate of reaction is concerned. That's we are studying in this chapter here. Okay, now let us move to the definition of chemical kinetics. Now move to the definition of chemical kinetics. This is a brief introduction regarding chemical kinetics. Okay, now what is the exact meaning of chemical kinetics and definition of chemical kinetics is that chemical kinetics, it is a branch of physical chemistry. Chemical kinetics, it is a branch of physical chemistry that deals with study of rate of chemical reaction. It is a branch of physical chemistry that deals with study of rate of chemical reaction, called as chemical kinetics. Also its factor, okay, is called as chemical kinetics. Okay. Then next point of our reaction is rate of chemical reaction. But before studying rate of chemical reaction, why chemical kinetics is necessary? Okay, now let us see. In thermodynamic chapter I am teaching you that reactant A or reactant A of species A is going to a distance B. Okay. A पासून B पर्यंत जायचंय with more specific ways. Path number first or path number 2. Second. Which way is better is not telling us for thermodynamics. In thermodynamics can't tell about number first or number second. Which one is better for us? Okay. Thermodynamics only concern initial state and final state of system. Thermodynamics only concern initial state and final state of system. Okay, but chemical kinetics is gives the information regarding which way is better for us. Okay, let us say कुठला मार्ग असा आहे की ज्याने आपल्याला इझी कमी ऊर्जा लागेल, कमी वेळ लागेल आणि स्पीड जास्त मिळेल याचा स्टडी केमिकल कायनेटिक्स मधनच होतोय. थर्मोडायनामिक्स फक्त स्टार्टिंग पॉइंट सांगतं, एंड पॉइंट सांगतं, तिथपर्यंत तुम्ही कसंही जावा, पण कुठल्या मार्गाने जावा हे फक्त सांगतं कोण? केमिकल कायनेटिक्स. ओके, नाउ दिस इज द ब्रीफ इन्फॉर्मेशन रिगार्डिंग केमिकल कायनेटिक्स. Now let us move to the some basic points. That is, number first, rate of chemical reaction. Rate of chemical reaction. Rate of reaction. Okay. Now what is the rate of reaction? Rate of reaction means how rate of consumption of reactant takes place and rate of formation of product takes place is known as rate of chemical reaction. Alternatively, I am giving you the another concept of rate of reaction in detail. So let us say an example, that is reactant A is converted into product P. Reactant A is converted into product P. Now in here rate of consumption रिएक्टंटचा वापर होतो and rate of formation takes place. रिएक्टंट वापरले जातात आणि प्रोडक्ट बनतो. So ultimately we have to write rate of reaction in terms of rate of consumption of reactant and rate of formation of product. Rate of consumption of reactant means the concentration of reactant is decreases and rate of formation means the concentration of product increases. Okay, so how to express or how to write rate of chemical reaction? Now let us see the initial definition or general formula of rate of reaction is change in concentration of species with respect to time. Change in concentration of species with respect to time is called as rate of chemical reaction. Now let's see, C is the concentration of reactant. Okay, then initial concentration is given by C1, that is C1 is the concentration for reactant. I can say only here initial concentration. Okay, now if C1 is the initial concentration, then C2 is the concentration of product, that is final concentration. And change is given by C2 minus C1. It is denoted by delta C. Change is given by C2 minus C1. It is denoted by delta C. This type of example we are studying in earlier in thermodynamic chapter. So don't worry about that. Delta C. Delta indicates reaction is completed. Okay, delta C. So let us move to the definition of rate of reaction. I am telling you general definition of rate of reaction. Change in concentration of species. Change in concentration of species with respect to time. change in concentration of species with respect to time is called as rate of chemical reaction. Change in concentration of species with respect to time called as rate of chemical reaction. Now let us move to the average rate of reaction. Average rate of reaction. Average rate of reaction. Average rate of reaction means what is that concept? Average rate of reaction. Let us say I am going to a distance here. My starting point is A. I want to go a distance to B, 100 kilometer. Okay, now my speed of my bike, not my speed, speed of my bike is, let us say 50 kilometer per hour. 50 kilometer per hour. मी 50 किलोमीटरच्या स्पीडने ए टू बी गेलोय. अंतर माझं 100 किलोमीटर आहे. 50चं स्पीड 49 केलं आणि ना 51 केले. ओके, नाउ I want to go A to B 100 kilometer. Now my speed is changing very. Let us say काही अंतर मी 60च्या स्पीडने गेलो, काही अंतर 30च्या स्पीडने गेलो, काही अंतर 20च्या स्पीडने गेलो. What is my exact speed? Now I am calculating my average speed. Now average चा अर्थ आपल्याला कळतो. My average speed is 40 kilometer per hour. This is the basic difference. It is called as rate of reaction. Rate means speed. Speed of my reaction is 50 kilometer per hour. Now my average rate of reaction, my average speed are 40 kilometer per hour. This is the basic difference for rate of reaction and average rate of chemical reaction. Okay, now we have to explain in more details by giving some detailing example. Okay, so let us move to the example number first. How to write a rate of reaction and average rate of reaction. Okay, let us say I think I am giving reactant A is converted into product P or product B. Okay, reactant A is converted into product B. Now let us see, I am telling you before rate of consumption of reactant is takes place and rate of formation of product is takes place. So I want to write rate of reaction in terms of rate of consumption of reactant and rate of formation of product. Rate of consumption of reactant. Rate of consumption of reactant. Okay, rate of consumption of reactant is given by change in concentration of species. Change in concentration of species with respect to time. Now my species is reactant A. So change is given by like initial concentration A1, final concentration A2. That is A2 minus A1, final minus initial. Delta in bracket A. Point to be remember that molar concentration is always expressed in square bracket. Molar concentration is always expressed in square bracket. So delta A divided by change in time, final time minus initial time. That is T2 minus T1. So delta T. Now here are the one twist. Let us know it. I am telling you concentration of reactant is decreases and concentration of product is increases. So in terms of reactant, negative sign is must be added for rate of consumption of reactant. So overall rate of consumption of reactant is minus del means delta. Let us say del, delta, etc. Minus del in bracket A divided by delta T. Okay, this is how to write rate of consumption of reactant. Okay, now consumption of reactant takes place and now formation of product. Now another equation for rate of formation of product. Rate of formation of product. P means product, R means reactant. I am saving my bottle ink. So rate of formation of product is equal to del B, change in concentration of species. Reactant B, the concentration always expressed in square bracket, del B divided by del T. Okay, now rate of consumption of reactant. In case of rate of consumption of reactant, concentration of reactant is decreases and concentration of product is increases. Decreases, hence I am giving negative sign in case of reactant. So increases, I am giving positive sign here in case of rate of formation of product. In case of rate of formation of product. Okay. That is how to write rate of consumption of reactant and rate of formation of product. Now I am going to write average rate of reaction. Average rate of reaction. Okay. Average rate of reaction means आता सांगितलेला आहे, we have to just write it. Average rate of reaction is average rate of reaction and average rate of reaction is nothing too much difference. Average rate of reaction, because study of chemical kinetics is mainly based on industrial purpose, not laboratory purpose, because in day-to-day lab there are many, we have to convert reactant into product as early as possible, as fast as possible. So study of chemical kinetics is very necessary to understand how reaction is going fast and fast, early as possible. Okay, so chemical kinetics, study of chemical kinetics is really very important for us. So how to write average rate of reaction? That is in equal manner, and next lecture I am proving why it is equal in manner. Del in bracket A divided by del T, sorry, not in bracket, time doesn't express in square bracket, only molar concentration expressed in square bracket is equal to plus del in bracket B divided by del T. This is how to write average rate of reaction. This is rate of consumption of reactant is equal to rate of formation of product, is called as average rate of reaction, or let us say rate of reaction. Okay, now you can ask me one question, why the negative sign is added to the reactant side and why positive sign is added to the product side. Explain with me, explain in details. So I am giving you the proper answer why negative sign added. I am just telling you the concentration of reactant is decreases, so negative sign must be added to the reactant side, and concentration of product is increases, so positive sign must be added to the product side. But this is not sufficient for us, so I am going to tell you in detail why negative sign and why positive sign is added to reactant and product side only. Okay, now let us say I can plot a graph. I am going to plot a graph, that is the graph of concentration, the graph of concentration versus time, the graph of concentration versus time. Now this is the graph for reactant. Okay, now what happened? The concentration, as I said you earlier, the concentration of reactant is decreases. So my graph is always in decreasing manner. So my graph is always in decreasing manner. Okay, here the time is equal to 0. Time increases, concentration decreases. Let us say concentration decreases. Let us say these are the first point. Let us say what is the concentration at time 1 hour. Okay, I am plotting or I am joining the points to the graph. Okay, Here are the concentration, that is C1, initial concentration. Then what is the concentration after time? T is equal to 2 hours. Let us say time is equal to 2 hours. Now I am joining the point to the graph. It is given by, the concentration is given by here C2. Let us say concentration of reactant is decreases. Now you can understand it easily, carefully. It is the 10 molar. So it is decreases. Here it is, let us suppose 8 molar. Here it is suppose 5 molar. Okay. Now C1 greater or C2 greater? C1 is greater than C2 or C2 is greater than C1? Let us say C1 is greater than C2. C1 is greater than C2. Graph says concentration decreases 10, so 8 मध्ये झालं, 8 चं 5 मध्ये झालं ना. टाइम वाढतोय ना. कॉन्सन्ट्रेशन हे वेळेबरोबर कमी होत जाते रिएक्टंटच्या बाजूने. आता T1 आपण याला T म्हटले तर या T1 आणि T2 म्हणूया मग 1 2 ची जर लँग्वेज असेल तर. सो T1 आणि T2 मध्ये मोठा कोण? दोन मोठं काय एक मोठं. ओके. T2 is greater than T1. T2 is greater than T1. Now what is the formula of rate of reaction? General formula of rate of reaction is rate of reaction, or rate of reaction is delta in bracket C divided by delta T. Okay. So this is the general formula of rate of reaction. Now you have understand it easily. Delta C indicates C2 minus C1. Delta T indicates T2 minus T1. So what is the calculation? The value of C2 is, I am taking the general value. C2, the value of C2 is 5 minus value of C1 is 8. Okay. Divided by T2 is 2 minus 1. 8 minus 5. Answer must be in negative figures. Answer must be in negative figures. Okay. So that's why I am adding negative sign to the reactant side only, not product side. Because in general, I am plotting a graph of concentration of reactant in y-axis and with respect to time in x-axis. Now concentration of reactant, in case of reactant, concentration of reactant is decreases. Okay. Here it is. I am taking just a random 1 hour, 2 hour. Here it is T1. Let us join the point. That point concentration C1, let us say decreases, hence 10, 9, here it is 8. Then after further going time, so time 2, T2 is equal to 2 hours. I am joining the point, here it is C2. So C1 8, C2 5. C1 is greater than C2 and T2 is greater than T1. Okay. Now how to calculate rate of reaction? It is really very easy. C2 minus C1 upon T2 minus T1. 5 minus 8 divided by 2 minus 1. The answer must be negative figure. Okay, so negative sign must be added to the reactant side only. That's why I am writing rate of consumption of reactant minus del B upon del T, whatever. Okay, this is the rate of consumption of reactant and why I am giving the explanation why negative sign is added to the reactant side only. Now why positive sign is added to the product side. I am also giving you the explanation in detail, so don't worry about that. Let us plot a graph of, again, I think the line is not straight. The mistake of my pen, not me. I think the concentration of product here in y-axis. Concentration of product versus time. Concentration of product versus time. Here it is that point time is equal to 0. Okay. In case of product, I am earlier telling you concentration of reactant is decreases and concentration of product is always increases. So concentration increases, so graph must be in increasing manner. So graph must be in increasing manner. So after time, here it is t0. Let us say it is 1 hour. t1 is equal to 1 hour. I am joining the point to the graph. E is equal to the concentration here are C1. Let us say. Then after time goes, T2 is equal to 2 hours. Okay. Now let us join the points to the curve. Let us here. These are the C2. Now let us move to the random values, that is concentration increases. I think here are the concentration is 0. Okay. Concentration 0, then it is 1, 2, 3, 4, 5. Let us say C1 is 5. 6, 7, 8. Let us say C2 is 8. Okay. Then C1 greater or C2 greater? Definitely C2 is greater than C2. Then T1 greater or T2 greater? T1 is equal to 1, T2 is equal to 2. So let us say T2 is greater than T1. Okay. Now, general formula of rate of reaction is del C ROR is equal to del C divided by del T is equal to delta C indicates C2 minus C1, delta T indicates T2 minus T1. So, putting the value of C2 in the equation is given by, what is the value of C2 here? I think it is 8. What is the value of C1 here? I think it's 5. So 8 minus 5, what is it? Time 2. It is 2 hours, it is 1. So answer must be in positive figures. Answer must be in positive figures. So that's why I am writing positive sign to the product side only. Okay, it is really very easy. Now I am telling you once again to this graph. I am plotting a graph of concentration of product versus time. As we know, the concentration of product is increases, so graph must be in increasing manner, curve must be in increasing manner. Then I am just taking random number 1 hour. I am joining the point. This point is called as C1, concentration initial. Then after time 2 hours, I am joining the point. This concentration is called as C2. Then let us say time 0, initial concentration 0, concentration increases 1, 2, 3, 4, 5. 6, 7, 8, increasing manner. Okay. Then C2 is greater than C1, T2 always greater than T1. Rate of reaction is given by C2 minus C1, T2 minus T1. The answer must be in positive figures. So that's why positive sign must be added to the product side and negative sign must be added to the reactant side. Okay, now I am taking a general example how to write properly rate of chemical reaction and average rate of reaction. Now let us take an example, giving another example or one more example to understand how to write rate of chemical reaction. Let us say C plus O2 which gives CO2. C plus O2 which gives CO2. Then you have to write rate of consumption of reactant, that is rate of consumption. Here are the two reactants, that is carbon and oxygen. Consumption of reactant carbon is equal to, negative sign is added to the reactant side, minus in bracket del in bracket C divided by del T. Really very easy. Then rate of consumption of oxygen, rate of consumption of oxygen is equal to minus, because oxygen is also reactant, minus del in bracket O2 molar concentration, always expressed in square bracket only. Then rate of formation of CO2, rate of formation of CO2, that is how to write rate of reaction. Rate of formation of CO2, positive sign indicates or added only to the product side, del in bracket CO2 divided by del T. Okay, this is how to write rate of reaction. Or now I am going to write average rate of reaction. Average rate of reaction. Average rate of reaction. Now listen it carefully. Average rate of reaction, you can just add consumption of reactant and formation of product in equal manner. That is called as minus, let us say, del in bracket C divided by del T is equal to minus del in bracket O2 divided by del T is equal to plus del CO2 divided by del T. ओके, फक्त काय करायचं, हे आहे तसे 1 2 3 आहे तसं इक्वल मॅनर मध्ये लिहायचं आपल्याला. त्याला एव्हरेज रेट ऑफ रिएक्शन काय इक्वल लिहायचं आहे ते तुम्हाला मी प्रूव्ह करून दाखवेन नेक्स्ट व्हिडिओ लेक्चर मध्ये. सो डोंट वरी अबाउट दॅट. ओके, नाउ व्हाट हॅपन, this is how to express or how to write rate of chemical reaction. What happen if the reaction having more stoichiometric coefficient? In previous example we can study only one carbon, last example of this format CO2. The stoichiometric coefficient of all reactant and product are 1 1 1. So what happened, reaction having number of coefficient, that is nitrogen having 1, hydrogen having 3 and ammonia having 2. The rule is changed. In next video lecture I am going to tell you how to write that type of example, how to express rate of reaction and average rate of reaction for that type of example. Hopefully you have understood this. Thank you.